morning, FPV. I was looking for a budget build to test out the new DJI O4 Air Unit Lite that would pair nicely with the Radio Master Pocket, which is more of a budget radio, as well as the DJI goggles N3, which is more of an entry-level HD set of goggles. So I actually had the Emax Babyhawk that was sitting in a box. It was really for an O3, bring your own VTX and camera, and it was really reasonably priced. It's sub 250 grams, flies fairly well. I've had the older version of the Babbyhawk, the non-O3 compatible version. So what we're going to do today is I'm going to go ahead and convert this to accept the DJI O4 Air Unit. And really all I need to do this is to print out these two adapters that just are spacers, and I'll link the STL files below and we can go through that. But if you look at the all-up cost of this, I actually only spent $139.99 for the quad itself, which is you can't source the parts individually and come anywhere close to that price. It didn't come with the Express ELRS module, but you can no longer get the plug-and-play version. They actually still have the bring your own O3 VTX. That is, instead of $139.99, it's $158.99 US, which is still reasonable because it's a lot easier build then, because you don't have to solder on anything. It's more of just to bring your own O4 unit with these adapters, and I'll go ahead and show you how you do that. As an aside, Albert Kim did a good video on one of the issues with the O4 camera is that this MIPI cable connector can separate from the main board of the camera in a crash. So you can just see there's this glue right here. You go ahead and add some B7000 glue right in between here and then on the other side. I'll go ahead and link his video so you can watch that. Prior to installing the camera into the 14mm camera mount, you're going to need to remove this protective lens cover. Then you're going to want to slide this on top, but being very careful. It's just a compression fit. You can see these tabs here that slot into the side of the camera. You want to make sure that you don't put any pressure on the MIPI cable. It's pretty fragile. This is what the camera should look like if it's properly seated into the 14mm camera mount. Here's an adapter I found on Thingiverse from Man Gorilla. Basically, it takes a O3 camera mount and converts it to a DJI O4 Lite camera mount. So you can see it's printed out in TPU. I did go ahead and remix it slightly. I needed to use some countersunk M2 screws. They're M2 by 6mm in length, so that I could basically, the Babbyhawk camera mount only has one hole for the bottom of the camera. So I wanted to use a nylon nut on this side so that I could cinch it down fairly tight so that I could set the angle and not have it slip. So you can kind of see how this works. And I need to do the same thing to the other side. I didn't have to reprint out this canopy. I just wanted to add a little bling by changing the color. And this is the easiest if you do this outside of the Babbyhawk frame itself. So since I was printing out these shims, I went ahead and changed it from black to this orange color. So I'll go ahead and link these parts below. This is actually from the Emax STL file. If you have a 3D printer, this works out pretty slick. Even if you don't have a 3D printer, you can. There's a lot of services that will print things out fairly cheap if you don't have a 3D printer, and even libraries now have 3D printers. So you can check that out as well. Interestingly enough, when I was just shooting this video, I just noticed that RDQ Race Day Quads came out with a new shim that you can just buy from them. That's a TPU. It's just like this one. It's an O3 to O4 Lite adapter. I'll go ahead and link that. Here's a screenshot of what it looks like. It looks like it should work as well, so just wanted to point that out. This is what it looks like with the O4 Lite camera installed into the Babbyhawk canopy with the shims. You can see that I can adjust the camera angle. I tightened it up enough with these lock nuts on the end to where, you know, it's tight enough that it holds it with friction, so that once you set the camera angle, it stays in place, but you can still rotate it. I'm going to be removing the top plate here by unscrewing these 5 screws that they have. This one, that one, and these 2 in the back. Top plate removed. I did have to push through this grommet. Everything stripped down, including removing the nose plate. This gives me better access to the flight controller board. Most likely you won't have to do these following steps because you'll most likely have the Express ELRS pre-installed version. I happen to have an older version that was available when I bought this, which was a plug-and-play. And I'm going to clip off this S-Bus cable harness. I don't need that. That's just going to get in the way. The wire harness that comes with the Babbyhawk is pin compatible with the O4 Lite, except for one thing. The power that comes in is actually this red wire, which is connected to VBAT, which is 4S, which is too high a voltage for the O4 Lite. So what we're going to have to do, we're going to have to move this red wire over to this pad that's next to the yellow wire, which is comes off the 5-volt BEC. It's a 2-amp BEC, so it's should be sufficient. The O4 Lite, even at 700 milliwatts, only draws 1.6 amps, so we should be fine there. There is the ELRS receiver that's also hooked up to that, but it doesn't use hardly any power at all, so we should be fine. Okay, I got everything soldered up. I'll just quickly go through the pad layout. I'll go ahead and display the Express ELRS pad pin layout. So at the bottom, you can see that it's the green wire is RX, the blue wire is TX, and then 5 volts, and then ground at the top. So that connects to the flight controller. The green wire is actually the RX connection to the flight controller's TX. And then the blue wire on the receiver is the TX on the receiver, but it's the input RX of the flight controller. So again, they're crossed. And then if you look at the power and ground, they're on the other side here. You can see the red wire is 5 volts going to the BEC, and then the black wire is, of course, ground. So pretty simple. And if you already have the one with the Express ELRS already pre-wired, you don't have to worry about this. And I went ahead and, as you can see here, I just tie wrapped the Express ELRS antenna to a cross member. You can see that. So next we're going to install the VTX and button this thing up. You're going to need to install these 4 rubber grommets. You can see that the thick part is pointing up because this actually hangs underneath and is attached to this 25 millimeter by 25 millimeter adapter plate. And then this actually sits on top of the frame here on the top of the standoffs, and then the top plate goes on top of that. So I'm going to go ahead and do that next. This is what the O4 Lite looks like when it's installed into the bracket. I used M2 by 10 millimeter screws, and what was interesting, the holes for the O3 Air Unit were smaller than 2 millimeter, so it was actually kind of self-tapping when I screwed these in. Probably didn't even need to have these nuts on the top because it's fairly tight, but it was fairly easy just to screw it into the existing holes. And again, it was kind of self-tapping. So maybe this is overkill, but I went ahead and put those on. I didn't use locking nuts because they're a little taller, and they were a little too close to the top plate, so didn't go with those. Before I move on, I wanted to show you how the whole assembly process works in the sequence for the top plate and the adapter plate that holds on the O4 Air Unit. So starting here, the first step is don't have this rubber grommet installed in the hole. Have it loosely outside of the hole, and that allows you to push the XT30 connector because it's TPU. You have some flex there. And then once it's the XT30 connector is pushed through, then you install it in the hole that's provided in the top plate. Then moving to the back, you're going to need to make sure that you push the antenna through the antenna mount holder, because you're not going to be able to do that after you install it with the screws. It is slotted, but it's slotted on the front. Not sure why they did it that way, but it should have been slotted on the back. Then the next step, if you notice here, the standoffs on the front are the tallest standoffs, and that allows you to give you the elevation to have the top plate a little higher than the adapter plate that holds on the O4 Air Unit. And you can see that these TPU Express ELRS holder here, that provides the gap between the top plate and the adapter plate. Likewise, on the rear here, the antenna mount provides the gap between the top plate and the adapter mount plate. And that also obviously allows you to put the battery strap in place. Then the next thing that I would do is just barely thread in, starting from the front to back, barely thread in these front screws. That way you can tilt up the top plate and get the Express ELRS mount situated, because you're going to have to go through 3 holes: the top plate hole, the Express ELRS TPU mount hole, and then the adapter plate hole. So then you do that next, and again, don't cinch anything down, just barely thread that one in, and then moving to the rear, then put these last 2 screws in to attach the top plate on the back, as well as attaching the antenna mount. So that's a sequence that worked for me. You might have a different sequence that might work for you, but again, it is pretty fiddly. Okay, this is what the finished product looks like. I have the props on. I did add just some foam landing pads here that I cut. So let's get a weight. It's 134 grams without a battery. If I use this beefy 850 milliamp hour R-line race battery, we're coming in at 232 grams, well under 250 grams. So this one definitely looks like it's a light build. I'm not going to go through the sequence of how you set up and activate the O4 Air Unit. There's a lot of good videos out there, including DJI and other content creators. I will point you to Oscar Liang's website, where he does an excellent job of showing how you activate the O4 Air Unit Lite and how you set up the N3 goggles and the O4 itself, and also shows the changes in the Betaflight configurator. This video would be way too long if I was to go through that as well. So I'm going to go ahead and link his website URL, where he goes through that in really great detail. So what I'm going to do is just show you the basic changes that I did in the Betaflight configurator, assuming that you've already activated the O4 Air Unit and set up the goggles correctly. So here are my thoughts on the stock tune. It was okay, it was flyable, but one of the concerns that I have is this is more of a hard-mounted camera mount, so you really can't use gyroflow to stabilize the footage. So that means you really have to dial in the tune. And because I was getting a little more prop wash than I normally like, I went ahead and modified things. So let's go through. The good news is Betaflight has the presets that you can use that really dial things in to where it's good enough. So let's start with what I did to set up the OSD. So what you would do is type in the search bar, you type in DJI, and you can see you can select different options here. I always pick the OSD for FPV. So you select that. There's a pull down menu and you want set HD OSD. You want the finer print and then map to display port. Then you need to pick the correct UART. In this case, it's UART1. You're going to pick that and then you're going to do save and reboot. I've already done that, so we won't do that again. The next thing is we want to set up the serial receiver. So what you can do there, you can just pull this down and select RC link. And you can see there's a lot of selections. I'm going to use Express ELRS 250 Hertz. And it does more than just set up the UARTs correctly and the configuration and ports tab. What this does is it actually fine tunes like feed forward. So you have these different selections. I selected freestyle, and then this is a serial, not SPI, receiver. I don't use telemetry, so those are turned off. So I'm going to pick that, and then do the same thing, save and reboot. So the next thing is setting up the tune itself. So we're going to go back. Select it all here, and we're going to type a search of 3.5 inch type quads, which this is. And you can see you come up with different selections here. And I really like mouse FPV tunes. They seem to really work well for me at the altitude I'm at and the type of builds I do. So in general, you want to pick a tune that's close to your build. In this case, this is the AOS 3.5 version 1, which is real close to what the Babbyhawk frame design is, and it's sub 250. So I selected that one, and it worked out great. So I have, this is not D-Shot 600. You need to select D-Shot 300. I left dynamic idle on, and that's all I did. And then again, you know, they talk about RPM filtering. It's okay. This quad can support RPM filtering, and the ESC can support RPM filtering. So you'd hit agree and then save and reboot. So those are the changes I made as far as presets. But let's go ahead and go through the setup and just so you can see what I did on each tab. Of course, if you're going to be flying in angle mode, you want to you know, put your quad on a flat surface and calibrate the accelerometer. You can see that mine's perfectly flat. I already did that. You're going to just double check the ports tab. It should be set up correctly based off the preset. Mine is. You can see that we're using UART2. That's what I soldered the serial receiver to. And then, of course, this is the MSP port for the O4 Air Unit. So configuration, I did change the craft name to O4, not a biggie. Didn't make any other changes other than setting the arming angle to 180 degrees. Very typical for freestyle pilots to set it to that so they can, if it gets caught in a tree, they can arm it and blip it out of the tree. Didn't do anything with power and battery, fail-safe, left that alone. We already talked about presets. PID tuning, you know, with the preset we picked, these are the settings. So the filter, you know, it's all set up now, ready to go. I did put my rates in, so no changes there. Just double check to make sure that the receiver is set up correctly. It'll say serial via UART and crossfire. Of course, when you selected the receiver preset, it sets that up automatically, but just double check things. And then in modes, this is the way I set up my quads typically, and it's just the way I order my channels. I noticed that they did, from the factory defaults, have it set up probably for the DJI RC controller. It's probably why they had like ARM on aux4. It was a little strange, so I'm assuming because you could set it up so it's compatible with the DJI RC transmitter. So you could do that if you so like. Nothing on the adjustments tab. So motors, this is a personal preference. I run props out, so I do that because it allows it to bounce off of trees instead of getting sucked into scraggle. And so normally I always set this to
reverse props, and that's really easy to do. You're just going to set the motor directions. I understand, make sure your props are off. And then I like setting things up individually. So just spin the motor, it'll be the wrong direction, so you can just change the direction by hitting reverse, and do that for all the motors to make sure that they're spinning in the right direction to match this figure here. And then, of course, we already talked about the OSD presets. I just used the one. It was set up automatically for me. So that's it. And the tune was great after that. And I'll show you some quick flight video.
So here are my thoughts on the budget/conversion build, starting with the pros. I think the number one thing is cost of the conversion. The Emax Babyhawk 03 with the bring your own VTX is $158.99. When you add the DJI Air Unit, you're now up at $267.99 US. I mean, that's a very compelling price to get into something with 4K HD capability. If you compare that to the Babbyhawk 03, that's a bind and fly, that's $509.99. So significantly cheaper. Then if you add in the DJI goggles N3, the Radiomaster Pocket Crush, a Tattoo R-Line 850 milliamp hour 4S battery, and a cheap charger like the ISD PD60, your overall cost for a ready-to-fly decent system is $596.96 US. So I think this is a great value. It will not be as good as a full custom DJI O4 Pro 3.5-inch quad, but it won't set you back over $500. So I think it has a great value. So let's also talk about the weight. It's well under 250 grams, as you saw. even with that beefy 850 milliamp hour 4S battery. So why is that important? Well, in the US, you can avoid having to have remote ID if you're not shooting for commercial purposes. So I think that's a definite advantage. And I personally like sub 250 gram quads. Anyways, they're not as noisy. So let's talk about also flight times. With the 4S 850 milliamp hour battery, I was getting around 620, 630 minutes of flight with mixed freestyle and cruising. And after I landed, my recovery voltage was at 3.6 volts. So I was well within, 3.5 volts per cell. So I actually had a little more headroom there, even at 6.5 minutes worth of flight time. The next pro is the 4K HD capabilities in onboard storage for $109. That's a steal in my mind. And I think DJI is definitely going after walk snail market space. And then the 1080p 60 hertz video feed is just crystal clear without any breakup. I was getting really good range with a cheap antenna and didn't have any really any significant dropouts in bit rate, as you can see here in the video. DJI came out with a new mode called race mode for racers that want to use DJI systems for racing. With the N3 goggles, you're looking at 24 milliseconds, and with the Goggles 3, you're looking at 20 milliseconds. So this is very competitive against the competition like Walksnail. So I think DJI has done a good job at reducing latency in this new system. Every build, has its cons. So let's go through those. So yes, again, you can build a custom freestyle quad that will be better. That's obvious, but this is going to cost you over $500 to do that. It's true that if you bring your own VTX and camera plug-and-play solution, you still have to do some soldering, which is just one wire, so it's not huge. And then you have to figure out, a mounting conversion, which I already showed you how to do. And then you can actually buy the shim to convert from an O3 to an O4 Lite from Race Day Quads. And then lastly, you cannot really use the gyro data because this is more of a hard mount in GyroFlow. I tried that and it was just too noisy. It's not a good solution if you're going to be using this for GyroFlow. But in my mind, if you were going to do that, this isn't the right quad. You would go with the DJI O4 Pro if you're into videography. But this is good enough for just capturing some 4K video of your flights, and so for that, it's totally adequate. So who is this build conversion for? I think it'd be great for new pilots that want to get into freestyle FPV on a budget and have something that actually flies decent. I mean, if you look at the overall cost, it is definitely compelling for a new pilot to dip their foot into FPV freestyle. So with that, I greatly appreciate you tuning into my channel.